Hi, everyone. I'm going to get started now. Thank you so much for coming. So my name is Sophie. I'm a data scientist with Stripe. And today I'm going to talk about lessons learned shipping our first application of large language modeling for Stripe support. You might be able to hear I'm a bit under the weather and I sound a bit gooey, but I'm going to rally for the next 30 minutes and I'm looking forward to it. So my goal today is that the next time you are solving a business problem using language modeling, these lessons will be top of mind and you will be better equipped for end measurable success. And ideally, my past headaches or woes can serve as good warnings or tips for you to avoid some of these gotchas when working with LLMs. So, for some brief context, Stripe is a payments company offering many different payments related products. And millions of companies from some of the world's largest enterprises like Google or Amazon to very brand new startups use Stripe to accept payments, grow their revenue, and in general, just accelerate their businesses. Stripe is available to businesses in nearly 50 countries, and our users can accept payments from customers in over 200 countries. So, as you can imagine, having a large global customer base and a wide suite of products means that our support operations org is extremely busy all of the time. So every week, our agents handle tens of thousands of support cases where they answer questions and solve problems for our customers. As the majority of our support volume is text-based data, LLMs are an especially exciting opportunity for support. So there's many applications where this type of ML can add value, perhaps summarizing our support case tickets after agents are finished solving them, maybe translating answers between different languages so that we can offer faster global support, or retrieving relevant information from our documentation when users need help. We could also classify what issues our users' support cases are about so that then we can make improvements to relevant documentation or simplify our onboarding flow where we see people have friction. It's also useful to just understand if our users are happy or disappointed based on the language they use in their emails or chats. However, for our first undertaking, we decided to jump in the deep end and target the root of the support problem space, which is the very complex but very high value task of answering our users' questions. So our ultimate goal here is to help agents solve cases more efficiently by prompting them with relevant responses to users' questions using GPT. So our customers will always talk directly to support agents, but we want to prompt these agents with relevant responses so that they no longer have to spend time doing really manual research or looking up answers to diagnose users' issues and provide the right instructions to resolve. This can be extremely time consuming given how complex and wide ranging the support problem space is. So for our success here, we need to make sure that our ML prompted responses are firstly, information accurate. We need agents to trust our answers and they need to be correct. And secondly, we need our ML responses to hit the right Stripe tone. So the human experience is extremely important to us, and we don't want our agents to ever sound like bots. Our ultimate measure of success is that agents are actually using this tool and it's helping them solve cases more efficiently. So, the first lesson that we learned is that LLMs are not oracles yet. Hopefully, this slide will become out of date very soon. Today, though, there has been so much incredible progress in this space, and there's a lot of very valid hype. But when it comes to very context-heavy business problems, LLMs still have important limitations, and they can be really, really subtle. So let's take, for example, a very common question that our support agents get asked every day. How do I pause payouts? The correct solution to pausing payouts at Stripe is to update your payout schedule to manual, which I appreciate is not super obvious. So when we give out-of-box GPT 3.5 detailed instructions and ask it the same question, how can a Stripe customer pause payouts? It does give a very plausible sounding answer, but unfortunately, this is factually incorrect. There is no such thing as a pause payouts button on a Stripe dashboard. Now, when we upgrade to using GPT-4, the answer does get a lot better. So GPT-4 knows that the trick to pause payouts is to swap to manual payouts, but the model goes a little off track discussing disputes, and the information isn't entirely factually correct anymore. So overall, advancing the GPT engine does improve answer quality, but there are limits of what a general purpose model can do. And we know to expect hallucinations that can be really deceptive. So this was just a very simple example, but this trend holds true for the majority of questions that Stripe customers ask. And that's because maybe the materials that GPT has been pre-trained on are either, out of date, perhaps incomplete, or maybe just confused with generic instructions that might relate to other payments companies. And yes, we can definitely improve GPT answers here by advancing to few shot inference instead of just zero shot. However, that's going to have trouble scaling to the hundreds of different topics Stripe users ask questions about every day. So we found that to solve problems that require this deep subject matter expertise at scale, we need to break down the problem into more ML tangible steps. First, we need to identify whether the user is asking a valid question or not. So this step will remove any chit chat or questions that don't have clear enough context, like, hey, how are you? Or, when will this be fixed? We don't want GPT to answer these questions unless there is enough context. So next, we identify what the topic this question relates to is. And then using topic relevant context, we can generate the answer to the question. Finally, we modify the answer so that it meets that perfect Stripe tone, which means that the response has the right friendly but succinct tone that our agents target. So our end solution here consists of a sequential GPT framework, which relies heavily on GPT fine-tuning on label data. It also employs a retrieval augmented generation or RAG-like approach to question answering. The first fine-tuned trigger classification model filters out any candidate user support questions that are not suitable. So any relevant questions that do pass through go to our fine-tuned topic classifier, which identifies what support material or documentation is relevant to answer the question. Then, using this information as context, our third fine-tuned model generates the information-accurate responses. And finally, our last few-shot model adjusts the answers to meet Stripe tone before being prompted to the agents. And the benefits here are that now we have a lot more control over our solution framework, and we can expect a lot more reliable and interpretable results thanks to fine-tuning. In our case, we actually completely mitigated hallucinations because we added a lot of thresholds to our models too. The other great benefit here is that fine-tuning on GPT requires just a few hundred labels per class, so we could move really quickly here, relying exclusively on expert agent annotation for our pilot. And being very honest, the team actually did a lot of the hand labeling required to train the trigger and the topic classifiers ourselves. And then we relied exclusively on our expert agents to provide the golden quality answers for our agent response model. So the second lesson we learned was how important it is to prioritize online feedback when monitoring. During development, we relied on backtest evaluations to measure ML performance. For our classification models, this was standard practice using label datasets and metrics like precision and recall. For our generative models, we engaged with expert agents who manually reviewed and labeled responses so that we could get quantitative results. And we also engaged with these agents for user testing, and training data collection so that they could own and dictate exactly what the ML response prompts should be for different types of input questions. So after many ML iterations, our offline feedback trended really well, and we got to the state where we were confident in ML accuracy and ready to ship. So for our production setup, we designed a controlled experiment to measure the effect of cases where agents are prompted with ML generated responses versus those which aren't. So we did have a lot of constraints on how we could set this experiment up. Because the volume of support cases eligible for our pilot was relatively small, we couldn't ring fence what agents were in the control versus the treatment. And instead, we had to randomize by the support case, and thousands of agents were included in the experiment, where they only saw ML generated prompts for a very small portion of the cases that they worked every day. The biggest gotcha, though, was that because online case labeling was not feasible at this scale, we had a considerable gap when it came to observing online accuracy trends. So once we shipped, we realized that the rate at which agents were using our ML generated prompts was much lower than expected. And this was a big shock to us, given how positive the agent feedback was during our user testing and how confident we were that our answers were correct, thanks to our offline evaluations. The reality was that very few cases were actually using our ML generated responses. And because we didn't have visibility into online accuracy trends, we were pretty in the dark trying to understand what was going on and whether there was a discrepancy between online and offline performance. So, in the absence of online accuracy metrics, we just decided to develop a heuristic based match rate to represent how often our ML generated responses matched the response that the agents actually sent to users. So, we showed them a prompt, we know that they didn't click on it, but we can check what they actually sent to the user and see if they are similar enough that we know that our prompt was correct. So this match rate provided a very crude lower bound measure on our expected accuracy, so we could tell how the model was trending. And this was really important to us to be able to validate the quality of our ML responses in production. So even though our offline user testing feedback was positive, and now we could tell that our online ML accuracy trends were good, in practice, agents were just too accustomed to their flow of solving cases and completely ignoring our prompts altogether. It turned out that lack of agent engagement was a huge bottleneck for us realizing the impact. And we really needed a much larger UX and agent training effort if we wanted to increase adoption. So there were many big learnings here. The first one is to always ask yourself whether human behavior can affect solving your business problem. And if so, engage with UX early. More practically for ML, we also learned the importance of deriving proxy online metrics in cases where we don't have the right data to measure accuracy or whatever metric we're targeting exactly. So directional feedback using heuristics is a million times better than being completely in the dark. We also learned to ship each stage of the framework in shadow mode as soon as they're ready, besides waiting for one large end-to-end ship. That way you can debug as you go and validate functionality per model and set target expectations for each stage of the pipeline. So in a separate model that I've just shipped recently, every time we shipped a stage of the pipeline, we would randomly sample data from shadow mode each day. And as a team, spend about 20 minutes reviewing, annotating to make sure that our online performance met our accuracy targets at each stage. And that really helped us. Lastly, this experience really taught us to prioritize monitoring efforts as highly as other ML development tasks. Often, monitoring is compromised as something that we can catch up on later after we've shipped. And this is especially easy to do when you're working on a really lightweight resource constrained team. But lesson learned that a model is not shipped unless it has full monitoring in a dashboard, because online feedback is really key to ensuring we're actually solving the user problem that we're targeting. So the last lesson to talk about today is how data is still the most important player when solving business problems using LLMs. I think there's a bit of a misnomer that newer or more advanced LLM architectures will be able to solve everything for us, and we just need to integrate or write the right prompt. But LLMs are not a silver bullet. Production requires data collection, infrastructure, testing, experimentation, etc., just like any other ML model. And the age-old 80-20 rule for working in data science holds true. So writing the code for our LLM framework took, like days, maybe weeks, whereas iterating on the data set to train each of these models took months. And I've definitely spent a lot more time in Google Sheets reviewing annotations, like searching for quality improvements of labels, etc., than I have spent writing Python code. In our experience also, iterating on the label data quality yielded much higher performance gains compared to using more advanced GPT engines also. This was because the types of ML errors that we were seeing related to gotchas in the Stripe support space, as opposed to more general gaps in language understanding. So adding more or increasing the quality of our data samples usually did the trick when we had a gap in performance. And we actually didn't end up using the latest GPT engines to reach performance results. We've also seen that scaling is much more of a data management effort as opposed to advancing your LLM framework. We actually found that collecting labels for generative fine-tuning models adds a lot of complexity. So for our second iteration of this solution, we've swapped out this generative ML component and replaced it with a more standard classifier or embedding classification. And moving away from generative responses towards classification is so that we can leverage weak supervision techniques like Snorkel machine learning or embeddings across our support documentation to label data and then classify it at scale. And we're also investing heavily in subject matter expertise strategy programs to collect and maintain this data set. So Stripe support space changes over time as we advance or as we grow our product suite. We need our labels to always be fresh and up to date so that our model is providing the correct answers that are relevant at that time. So our goal is that this data set becomes a living oracle that will guarantee our ML responses remain fresh and accurate into the future. So to recap, the goal of this project is to help our support agents solve cases more efficiently by prompting relevant responses to users' questions. The three big lessons from this talk are: number one, LLMs are not oracles. Make sure to break down your business problems into ML manageable steps. Number two, online feedback really is key. Monitoring is a priority just as much as other ML development tasks. And number three, data is king. So a good data strategy will outperform a fancy model architecture, especially for solving business problems that require deep domain expertise at scale. So very happy to take questions in the chat, or else please reach out to me on LinkedIn if you'd like to chat more about any of these topics. And I also have a very obligatory plug for open roles at Stripe right now if anyone would like to join us and work on problems like this. So maybe going through the chat, I'm sorry I ignored it while I was presenting, and I'm sorry that the text was hard to see. I can share the deck afterwards if people are interested. So the first question is, can you expand on how did you choose the infrastructure and measures taken to keep the compute cost down? Oh, that's a great question. And I feel like this was such a pilot program that when we were first working on it, because the scale of the pilot was relatively small, compute costs were kind of lower priority to us. We first wanted to validate, could we solve this problem? And then afterwards, once we had feasibility work out, okay, how much is it going to cost? And is that feasible for ROI? But in hindsight, because we use smaller engines, the compute costs were really manageable. And we did have a strategy. So as you see, some of these fine-tuned models, as soon as we collected enough data, this could be an in-house model. The concept of trigger classification isn't actually that complex that we need an LLM. BERT will do great if you have enough labels. So I feel like we had a strategy also to use GPT as a mode to collect training data at scale and then benchmark against an in-house model and see if we can downgrade the complexity of the model for tasks that don't need them. And does that answer your question? Let me know. Um, the next question is, can we elaborate on shadow mode deployments? Yes. So it really isn't anything super fancy. Like we don't have a separate environment. Typically, we would ship to production, but instead of actually actioning the model, we would just apply a tag so that we would be able to support all of our end metrics in our tables. This is really hard to navigate with all the animations. So that we would basically get our dashboards like this, where we would have trends on what volume we're expecting and trends on our accuracy heuristics. But we called it shadow mode because we weren't actually actioning in them. So, our model would predict that it's topic related to X, and this was the answer we would provide. Let's just monitor the volume that we're predicting topic related to X and see if it's on trend or if there's any gotchas. It's really helpful for shipping in shadow mode like that so that we can actually assess our targets. I feel like oftentimes I backtest them, um, but it's always nicer to see it validated in production in your daily metrics. So a follow-up question on that is, how would we shadow deploy without getting online feedback from our support agents? So in this case, we could still get our heuristic metrics because we were just matching to what the agent actually sent. So we could derive like certain heuristics. Like if we were predicting a certain topic, we would define what rules related to the case would signal that this is a correct topic prediction. So that way we could do it in shadow mode without actually interfering with the agents. Um, and oftentimes we would just manually review also. So we would have like a dashboard that would have the entire population so that we could see the trends and make sure they're directionally correct. And then we would randomly sample X cases per day and sit there as a team and spend 20 minutes each reviewing so that we could validate that our like golden quality labels matched our heuristic online metrics. That makes sense. And we often didn't include all of the suite of agents just because there's so many and they have like a very busy schedule. Whereas when we consulted with our experts, then we would get sanity check. If we needed annotations that were like beyond our skills depth, then we needed the experts to help us. Hopefully I've answered the shadow mode shipping for LLM. In our case, like I know certain jobs I've worked in the past, they would have separate environments for QA or for production. In our case, though, we still ship to production so that our models were, in the correct environments, but we just switched off any actions. And instead, if our model predicted something, we would write that as a tag. And then we could use all of our metrics feeding from those tags, but knowing that actually we haven't, sent any responses or taken any actions until we have sanity checked that the model is performing online as we expect. Um, can you elaborate more on how you used heuristic search to get feedback? Is that the heuristic metrics? This was really hard. Literally, we were coming up with rules to signal whether a case response, like an actual agent's response, matched what our ML prompt said. And like you can do some fuzzy matching on the actual text used, but oftentimes agents would like um, add in a lot of like embellishment. So even though the content was the exact same, they would have added in a lot more like kind of flowery language. So the similarity distance between those two text chunks would be different. So we came up with some other heuristics on like what state the case was in, if it had certain keywords, and the length of the text. And then we manually validated by sampling and annotating ourselves. But the trends were pretty good. I think there was a strong feature related to what tags are applied to the case, which we have from like just the support data to signal whether or not our ML prediction was accurate or not. Were there any offline metrics you valued as a North Star before going online? That's a great question. Um, I feel like we had monitoring metrics related to accuracy and tone, and accuracy was the North Star because we wanted to build trust. And also, this was the first time that we were adding any sort of automation. So I think there's a really high bar because our agents are like top class. So if we're going to try and shortcut some of their really hands-on work, we need to make sure that we're meeting the bar with respect to the answers that they provide. So we did have a lot of evaluations where we just relied exclusively on annotations to make sure that we were hitting our targets for accuracy. And then when it came to like production metrics, we kind of changed. So accuracy was a good monitoring metric, but we also cared a lot about the user experience. So once we shipped, we wanted to make sure that any case that had some sort of ML engagement still had really high like user experience metrics like CSAT, or like the case, was actually more efficient. Like, did we actually help speed up how long the user was waiting for an answer? Because our goal here was efficiency. So maintain high quality as per agents, but also, improve the flow so that we're answering our users' questions a bit more efficiently. Hopefully that makes sense. And last question, I think, is can you explain the team structure? What were the specific roles hired, or did folks involved with the ML implementation were brought up to this project? Yeah, so we were super lightweight at the beginning because it was kind of, I don't want to say a moonshot project because it's, the uncertainty wasn't that extreme. It's not as if we were doing something really outlandish, but we were pretty lightweight because this was a new feature add. So the actual team, we worked with product folks and a lot of support operations experts. I feel like they were the meatier side of the team to make sure that we were getting the right business context. And I was a data scientist on the team, and we also had a software engineer. And I think in hindsight, if I was to go back in time and resource now, given that like we know it's a successful avenue to pursue, I would bulk that up with UX engineers, machine learning engineers. Like I think for shipping a pilot, it's very easy to be scrappy and like um, focus on the quality and the business problem. But then when you're maintaining a machine learning model in production at scale, like you want to make sure that your infrastructure is sound. And I feel like that's where having machine learning engineering support in parallel is really important. And also product and user experience. I'm trying to think if there's other things that we've missed out on here. I think that makes sense. It feels like a pretty cross-functional team with a lot of coverage in all of the areas of expertise across engineering, business domain, data science, and machine learning. Um, is there any more questions? Oh, thanks so much for telling me. It's a good presentation. I feel like presenting for 30 minutes takes a long time to prepare, even though it's just a short talk. So thank you for feedback. Um, okay, great. I think that's all the questions. Please reach out if there's anything else that I've missed. And thanks so much for coming, and thanks so much for asking questions too.